Hello everyone, my name is Faiblert and today I will present my Thermofluid Engineering 2 Assignment 1. My topic is AHU psychometric analysis, which I will compare a 100% fresh air system with a max air system. An AHU or air handling unit is used to condition air before supplying it into a room. In this assignment, the AHU needs to supply air to a multipurpose room in Malaysia. The outdoor air condition is used in 34 Celsius and 80% relative humidity, while the final indoor target condition is 24 Celsius and 55 relative humidity. The main end of this presentation is to explain the psychometric process, calculate the cooling load, moisture removal, and reheating load, and then compare which system is more energy saving. Next slide. For my presentation, I will follow this flow. First, problem setup. I will explain the problem setup, including the climax, condition, AHU target, or assumption. Okay, second, I will explain question 1, which is the 100% fresh air system. I will cover the process, the ordering like psychometric part and room calculation. And the third, I will explain this question 2, which is the max air system. After that, I will compare both systems in terms of cooling route, reheating route, moisture removal, and trade-off. Finally, I will end with the conclusion and also the final judgment. All right, next slide. Okay, Malaysia has a tropical climate, so the outdoor air is normally hot and humid. Because of this, the AHU needs to remove both sensible heat and latent heat. Sensible heat is related to temperature reduction. Okay, latent heat is related to moisture removal from the air. For the assignment, the selected outdoor condition is 34 Celsius red but temperature and 80% relative humidity. The airflow rate is fixed at 120 meters cubed divided minute, and the atmospheric pressure is 101325 bar. The required indoor comfort condition is 24 Celsius and 55% relative humidity. This is used as the final supply or room condition. The air comparison is between two systems. The first one uses 100% outdoor air, while the second one uses 30% outdoor air and 70% recirculate room air. Next slide. For question 1, the AHU use 100% fresh outdoor air. The outdoor air first enter the cooling and dehumidification coil. In this coil, the air temperature is reduced and moisture is removed through condensation. This means the cooling coil removes both heat and water vapor from the air. After the cooling coil, the air reaches stage 2, which the coil as its condition. Okay, in my analysis, stage 2 is less as 14.41 Celsius and 100% relative humidity, and the air pass through the reheat coil. The purpose of reheating is to increase the air temperature to the comfort condition without changing the humidity ratio. Finally, the average stage 3 is 24 Celsius and 55 relative humidity. This system for condensation remove is 2.252 kg divided meter. Okay, next slide. This slide shows the property of the outdoor air at stage 1. It's like the humidity ratio I use is W1, which is 0.027286 kg divided kg dA. This value is actually quite high, which means the outdoor air contains a large amount of water vapor. The specific enthalpy is, I use H1, which is 104.17 kJ divided kg dA. It shows that the outdoor air contains a high amount of energy because it is both hot and humid. The dew point temperature is 30.06 Celsius. This is very important because condensation starts when the air is cooled below this temperature. The specific volume is 0.9083 meter cubed divided kg dry air, and this value is used to calculate dry air mass flow rate. So from this value, we can see that the outdoor air is a heavy cooling load from the AHU. The next slide. This slide shows the psychromatic process which I use the A, B, C, D points. Point A represent the outdoor air condition with 34 Celsius and 80% relative humidity. From A to B, the air undergoes sensible cooling. During this process, the air but temperature decrease. Why? But the humidity ratio remain constant. All right. Point B is the dew point of 30.06 Celsius. This is where the condensation starts. Okay, from B to C. The air undergoes cooling and dehumidification along the saturation curve. Okay, during this process, water is removed from the air. Point 3 is the cooling coil axis condition, which is 14.41 Celsius and 100% relative humidity. From C to D, the air is reheated. During this reheating, the humidity radius remains constant. So W2 equal to W3, which is 0.010242. Point D is the final supply condition, which is 24 Celsius, and also the 55% we have this humidity. This percent show why dehumidification and reheating is unneeded in tropical air condition. Okay, you can see this slide. Next slide. Okay, this is also the value or a value calculation for question 1. The dry mass flow rate is MDA, which is 2.202 kg divided second. The moisture removal rate is MW, equal to 2.252 kg divided meter. This moisture removal is quite high because the system uses 100% outdoor air. The cooling coil is calculated using the Q with the dot, also with the N dot of above cooling equals to N dot above DA times the H1 minus H2. Okay, if you sub the value, it becomes 140.45 kW. The reheating load is called the reheating load 2.202 times 50.216 minus 40.38. So you can get the value, which is the 21.64 kW. This shows that the 100% fresh air system requires a high cooling load because the outdoor air is hot and humid. Next slide. Okay, the process. Okay, this is the system is changed to a max air system. Question 2. Instead of using 100 outdoor air, only 13% outdoor air is used. The remaining 70% is recirculated from room air. The outdoor air is at 34 Celsius and 80% relative humidity with enthalpy, which is H1. I have H1 124.17 kJ minus KDA. The second room air is already at the window condition, which is 24 Celsius and physical relative humidity with enthalpy about the H3 50.22 kJ divided kGDA. Both air stream enter the maxing box. After maxing, the air condition becomes 26.94 Celsius and 67.8% relative humidity. And then the max air pass through the cooling and dehumidification coil reach the coil axis condition and is reheated to the final supply condition. The key idea is that the max air entering the coil has lower enthalpy than 100% outdoor air, so the cooling load is reduced. This slide shows that the property of the max entering the cooling coil, the value, the dry air max flow rate of outdoor air is 39.63 kgdf divided minute. The dry air max flow rate of recycled air is 98.17 kgdf divided meter. Since the maximum process has some to be adiabatic, the max air humidity rate and enthalpy are found using the dry air max weighted average. The max air dry bulb temperature is 26.94 Celsius and the max air relative humidity is 67.8%. The humidity ratio is W max which is 0.015144, and the enthalpy is 65.73. The important point is that the W max is larger than W2. This means that the max air still contains more moisture than the final required condition. Therefore, the dehumidification is still needed, but the moisture removal is much lower compared with the 100 fresh air system. This slide shows the cooling load, reheating load, and moisture removal of the max heat system. The cooling rate is calculated using the Q calculator is using the NDA max and times the hash max minus hash 2. And the sub the value you can get is 58.2 kW. The rating load and is 2.297 times 50.216 minus the 40.38. You can get the value which is the 22.57 kW. The moisture removal rate is the 0.675 kg diameter. Compared with the question 1, the cooling rate reduction is 140.45 minus 58.2, which is the 82.25. Okay, well, this gives us the 58.6. The 58 for X reduction in the cooling coil is cooling load. It's like compared to two systems. So the 100% fresh air system, the cooling coil is 140.45 kW. For the max air system, the cooling load is 58.2 kW. So the max air system reduced the cooling coil by 58.6%. So the moisture removal also reduced from 2.252 to 0.675. The rating level is slightly higher from the Air Max system, increasing from 21.64 kW to 22.57 kW. This happened because the dry air mass flow rate in the Max Air system is slightly higher. However, the increase in reacting route is small compared with the large reduction in cooling load. So the main trade-off is IAQ, which is indoor air quality, since the Max Air system uses less fresh outdoor air. Ventilation must be controlled properly to prevent carbon dioxide or indoor pollution from building out. It's like explain why sensible cooling alone is not enough, because sensitive cooling only reduces the dry bulb temperature. It does not remove moisture from the air. For the outdoor air, the humidity ratio is 0.0272 x kg divided kgDA. For the required indoor condition, the humidity ratio is 0.010242 kg divided kgA, since the W1 is larger than the W3. So the outdoor air has too much moisture. If the outdoor air is only as sensibly cooked to 24 Celsius, the humidity ratio will remain the same. This means that the air will still be too humid and cannot make the indoor comfort condition. The outdoor air dew point is 30.06 Celsius, so condensation starts before the air reaches the 24 Celsius. Therefore, the correct ASU process is cool before dew point. Remove the moisture and then reheat. And this is why cooling and dehumidification and reheating are all needed, very important. Okay, conclusion, final. In conclusion, the 100% fresh air system requires a high cooling load because the outdoor air is hot and humid. So for question 1, the cooling load is 140.45 kW and the reheating load is 21.64 kW. For the question 2, the max air system use 30% outdoor air and 70% circulation room air. This reduces the cooling load to the 58.2 kW. The cooling reduction is 82.25 kW or the 58.6%. This shows that the max air system is more energy efficient. However, the max air system must still provide enough air to maintain good indoor quality. Also, the sensible cooling alone is not enough for typical outdoor air because the humidity is too high. Purification is required before reheating. Overall, the best energy design should balance energy saver, moisture control, and indoor air quality. So next slide. Thank you. This is the end of my presentation. Thank you for listening. Goodbye.